right, so let's do some integration with trig stuff. So we're kind of continuing our thoughts from yesterday and what is integration. And we know that if you have your trig derivatives memorized, then you also have your trig integrals memorized. So who has a derivative of cosine? Well, who has a derivative of cosine? That would be sine of x, and we have to remember that constant of integration, so sine of x plus c. Who has a derivative of sine, or in other words, what is the antiderivative of sine of x? And that would be negative cosine of x plus c. Who has a derivative of secant squared? That would be tangent. Who has a derivative of secant tangent? And that is secant of x. So I'm just doing all my trig derivatives, but kind of in the opposite way. Who has a derivative of cosecant squared? Well, remember the derivative of cotangent is negative cosecant squared. So if I just put the integral of cosecant squared, that would be negative cotangent plus c. And finally, the integral of cosecant, cotangent would be negative cosecant. So our formulas, we got to have those memorized. Remember, I kind of showed you this with derivative taking. It might be helpful. If you think of the unit circle and you write, remember over here, cosine is positive here and cosine is negative over here. We have sine is y and that. It's kind of a little pictorial that might help you. Remember, first semester we were doing derivatives, so the derivative taking is going this way. The derivative of sine is cosine and around the circle, so the blue is the derivative taking. Can't spell derivative. So the blue is the derivative. Well, now we're going the other way. If we go in a counterclockwise way, like this, so the integral of cosine is sine. The integral of sine is negative cosine. And so the pink is, of course, the integral. So if that helps you with the signs of these, it might be good because, you know, if this is on multiple choice and one little sign mistake causes you to miss it, that's not good. So let's look at example 1. Again, being that this is our first time through, I'll do a property that probably you're not going to end up writing, but remember that I can take the constant out and then I can take the individual derivatives of these things. So I could pull a constant of negative 5 and take the integral of sine of x dx. And as we just discussed, the integral of cosine is sine, so that would be 4 sine of x. And then the integral of sine is negative cosine, so if I combine that with the negative 5, that's going to be plus 5 cosine of x, and then plus c. And people always ask, well, if you separate it like that, shouldn't there be 2 plus c's? Well, you have a constant and a constant, so I could add those together, and that's just another constant. So even though you're splitting them, you're only going to have 1 plus c there at the end. Let's look at example 2. So for this one, we have a product. Remember, we can't do the integral of a product unless he happens to be the derivative of somebody. So let's rewrite this guy. Before we take the derivative, let's go ahead and multiply this through. So I'd have secant of y, tangent of y, minus secant squared of y, and you want to integrate with respect to y. And so again, you can look at those separately, and this is the derivative of somebody. Secant tangent is the derivative of secant? And then who has a derivative of negative secant squared? That would be negative tangent plus c. There you go. And I can, of course, combine, trig and non-trig. That's okay. So again, I'm just kind of going down the line. I'm going to go straight to the answer on this one. Who has a derivative of cosecant squared? That's going to be negative cotangent. And then I do power rule on everything else. So that's going to be x to the 4th dividing by 4. 8 divided by 4 gives me 2. That's going to be a x squared divided by 2. So I have a 1/2 there. And then a plus 4x. And I can't forget my constant of integration. And there is my answer. So just, again, some memorization. And then you can add that on to what you already know. Let's look at the back. So the back says, find the equation for y given dy dx is x squared and through the point 3, 8. Well, this is an example of something called a differential equation. And how are you going to solve that? And just giving you the picture of what's going on, it's kind of the same thing that we've kind of talked about in that there are many different functions that have a derivative of x squared. And you kind of go, well, it's going to be a cubic, so, you have that. But which, you could say x cubed plus 2 would have that derivative, x cubed plus 5, x cubed minus 7. But only one of them is going to go through this point. So let's talk about how we're going to solve this differential equation. And it's a specific type called a separable one. And in our class, in our course, the only differential equations that we'll actually be solving will be separable ones. And that means what? Okay, if I have dy dx, well, let me not put the integral symbol yet. If I have dy dx is equal to x squared. Well, what I'm doing is I am taking the integral with respect to dx and dx. Now, probably you're not going to actually do this step. You're going to kind of shorten this process. So it ends up being, it looks like the integral of dy over the integral of x squared dx. So in other words, I've separated those variables. So yeah, you can just pop that dx to the other side. And when you integrate dy, 1 with dy, you get y. And you integrate the other side and you get your 1/3 x cubed plus c. I just wanted to show you this step because if you do go on to further math, I don't want you to think that you integrate the sides with different variables, although it looks like that. Originally you didn't. You did them both with dx and then it becomes that. But yeah, I'll be honest, I'm going to start just going to that step and doing it that way. So I have y equals 1/3 x cubed plus c. Now that is called the general solution to the differential equation because all you use is this part. But this is called an initial condition. I'm going to use that initial condition and I'm going to plug in 3 for x and 8 for y, and I can then use that to solve for c. And so 3 cubed is 27 divided by 3, that would be 9, plus c is equal to 8. So c is equal to -1. Now make sure that you don't write c is equal to -1. That's not your answer. Your answer is when you're solving a differential equation, your answer is an equation for this guy in terms of this guy. So my answer is y equals 1/3 x cubed, I'm going back to this right here, minus 1. And this, and that's actually called something, that is called the particular solution. And we'll be doing more differential equations kind of at the very end of our semester, I mean right before the AP test. So, but if you see that word particular solution, you are solving the differential equation. So let's see if we can do one more. It says find f of x if f double prime is that, and then they give you some information. Well, let's recopy that problem. If I have f double prime of x, I have all this stuff. Well, what do you think I'm going to do? If I'm trying to get from f double prime to f, what do I have to do? I have to integrate. So I'm going to integrate with respect to x and integrate with respect to x. Well, if I integrate f double prime, what does that give me? Well, that gives me f prime. Let's do the integration. Increase the power by 1, divide by the new power, 12 divided by 3 is 4. Go down the line, x squared, divide by 2 would give me 3, minus 4x. Do not forget your constant of integration right there. Now notice they gave you this information. F prime of 0 is 5. So when I plug in zeros for all these x's, I better get out 5. So that c is 5, which means I'm at f prime is 4x cubed plus 3x squared minus 4x plus 5. And then I just get to repeat the process because it didn't ask me what f prime was. It asked me what f was. So once again, I'm just going to integrate with respect to x. That would give me f of x. And when I do the integral, x to the 4th divided by 4 would be 1. That would give me x cubed minus 2x squared plus 5x plus c. Different c, obviously, and I'm going to use this information when I plug in 1 for x. I better get out 8. So what does that give me? 1 plus 1 minus 2, that's not, so 5 plus c is equal to 8. So c is equal to 3. And remember, what's my final answer? Find f of x. So f of x is going to be x to the 4th plus x cubed minus 2x squared plus 5x plus 3. And there's my particular solution. So that is the only function that has the second derivative of this and these two statements true. So again, that's called the particular solution. This one is called the general. General solution, thousands of examples, thousands of answers. Particular solution, there's only one. All right, there you have it. Peace out.